Hi everyone, my name is Sam Gold, and today I'll just be running through a machine learning model that I made on Microsoft Azure Machine Learning Studio to analyze and find artifacts in EEG data. So to preface my machine learning model, an EEG is an electroencephalographer. So what it does is it measures brainwaves non-invasively using electrodes placed on the scalp. And so one of the big problems with EEG data right now is something called artifacts. And artifacts are little things like eye blinks or jaw clenches that come up as much bigger disproportionate readings on EEG readings. So what we're trying to do here is we're trying to train a machine learning model to identify these artifacts so that scientists can then use the machine learning models to weed out the artifacts from the actual data that they want. So let's dive into how I made it. So the first step is finding a data set. So you can use, I went to the UCI, so the University of California Irvine machine learning repository. So that has just a crap ton of data sets in virtually any field you want. I chose one, obviously, that fit the context here, which was artifacts and BCIs and EEGs. So this is an EEG data set that measured eye state, so whether the eyes were closed or open. So you see we have 16 columns, the first column being the ID column, column 1 here, and then the rest are EEG readings. And then the final column is the state of the eye, so 0 being open, 1 being closed. There's a lot more columns here. However, they're only displaying the first, how many? I think it's 100. 100 columns. You'd actually find a ton of columns that are labeled 1. So then what we did was we went to select columns in data sets. So we selected all the relevant columns, essentially just all of them except the ID column, because the ID column obviously doesn't pertain to our machine learning model here. Then we cleaned missing data. This is really a best practice because a lot of data sets will have missing data. But as you can see in the data set here, there is actually no missing data. So it's a really, really super amazing data set. No missing data there. So then we split the data. I did a 0.5 split. So that's sending half the data to train the model and half the data to score the model. You can set that to anything. Why don't we try changing it to 0.75 here, just to see what happens. And then I used a 2-class decision forest. But again, you could use anything. So here's what we'll do. We'll go and we'll run the machine learning model and see what our accuracy is for 0.5 and the 2-class decision forest model. And then we can check out different alternatives and different splits, and we'll see what happens. So here is what we got. So to find and to see how accurate your model was, you go to the evaluate model block, the score model block goes into that. And then you press evaluation results, visualize, and then it'll show a nice graph here. See that true positive rate, that's our scored data set, and then our false positive rate, virtually none. So then we see our accuracy of 0.87. So this is a pretty good accuracy. It's not nearly the best we could have attained. If you look at a coworker or a colleague, Aryan Harshith's, he attained an accuracy of 94% using a very similar model. He used a different decision-making process, and he split the data at 0.75. So why don't we see if we can try to replicate what he did here. So we split it at 0.75 now. See, that's there. And then what he used was a 2-class boosted decision tree. So we get rid of this block. We put that on there. We drag that there. There we go. And then we run the experiment. We'll see how it performs. So now we go to evaluate model. let's take a look at our results here. Okay, accuracy of 91, 0.91, so it's 91% accuracy. So that is truly incredible. That is higher accuracy than virtually any other machine learning model on, like, this is on par with what the highest caliber machine learning models are getting right now, which is truly, truly insane. That you can do this at home on your laptop with no coding required. Like, I don't know how to code, but I was still able to create a machine learning model that performed at extremely, extremely high accuracy. So that was just a brief rundown of my first focus replicate for my TKS program. And I just wanted to showcase how you can make a machine learning model at home using Microsoft Azure. Thank you.